In this particular video, we're going to talk about integration exponential functions. You can be given different questions and then you're expected to. So we're going to really discuss various techniques you need to know for you to do integration of different questions as far as your exam is concerned. So the first part we're going to look at, whereby you are given an integral. For instance, you are given this integral and then you are expected to find the integral part of that. So if you have exponent f of x and you're supposed to integrate that, the first thing to do is to find the derivative of the power. So the answer is going to be 1 over the derivative of the power times the function that you are given, then plus c. So we can also simplify this into you have integral of e raised to the power of ax plus b, and then we are going to find the derivative of the power. So we say d of d of x over the power, and then we shall write the exponential function a plus c. Let us go ahead and look at the example that can enable us really see how we apply this formula that we see at this particular. So the first example that we're going to look at is evaluate from 0 to 3 e to the power of x dx. So we're going to look at the power as a function. So this is going to be 1 over the derivative of x. Finding the derivative of x or differentiating x, you are going to get 1. So 1 over 1 is going to be 1. That's why integrating an exponent e to x is going to be what? Is going to be e to x. So we're going to have that there. And then now we can be able to substitute what we have into the function that is inside the bracket. And that's going to be e to the power of 3 minus e to the power of 0. And that's going to be e to the power of 3 minus 1 as the final answer for that shape. Now we need to look at another example on the same so that we can see how can we be able to apply more into other questions. So we're supposed to find the integral of 2 e to power 8x minus 3 with respect to x. So we're going to factor out 2, and then we're going to remain with e to the power of 8 minus 3. Then now you can see e to the power of 8 minus 3. It means we can be able to find the derivative of 8x minus 3. Then we say 1 over the derivative of that. And I believe you remember what we said. We are finding the derivative of this part. So that's going to be 8. If you differentiate 8x minus 3, we're going to get 8. So it will be 1 over 8. Then you write the exponent function the way it was given that case. So if we simplify this, we're going to get our final answer 1 over 4 e to the power of 8x minus 3, then plus c. Don't forget to write plus c at the top there. Okay. Now we have example 3, whereby we have 1 over 4 exponent of 2 cos x plus 1. You are integrating with respect to x. Now in such scenario, what are we going to do? We are going to factor out first 1 over 4 so that we remove 2 cos x plus 1, and then we're going to find the derivative of the power. We're going to find the derivative of power, and that's going to be, if you differentiate 2 cos x, remember differentiating cos x is equivalent to negative sin x. So differentiating 1 is 0. So the derivative is going to be b of that plus c. Remember to include that. And if we simplify this, we're going to get 1 over 4 times 1 over negative 2 sin x at this point. we write the function the way it was, exponent 2 cos x plus 1, then plus c. So if we simplify this further, this is going to translate to negative 1 over 8 sine x e 2 cos x plus 1. So basically, that's what we are supposed to do. Now we're going to go further and look into function like this. If you have 1 over x, if you find the derivative of 1 over x, what does it give us? The derivative of 1 over x is going to be, we factor out 2, and then this is what we have. The derivative, okay. The integral of 1 over x is ln of x. So this is going to end up being 2 ln of x plus c. But if you have a function, f of x is a function, we're going to say the integral of this is going to be given as 1 over the derivative of that function, then ln of that function, then plus c at that particular point. So we're going to say in our example that if you have 4 over 2x plus 1, you see 2x plus 1 is a function of x. So how are we going to go about this? We're going to factor out 4 in the first place. 4 will go out. We remain with 2x plus 1. But since this is a function, 2x plus 1 is a function, we are going to say this part, we find the derivative of this part. So we shall have this as 4 times 1 over the derivative of this part that I've highlighted, 2x plus 1. The derivative of 2x plus 1 is going to be 2. If you differentiate 2x plus 1, you're going to be 2. Then write that ln of. So this is going to be what we're going to say there for now, ln of the function. Then we are going to say plus c. And if we simplify this, we're going to get 2 ln of 2x plus 1, then plus c as our final answer. If we are getting value from this particular video, consider subscribing so that when we're going to upload more tutorials on this game, more tutorials on, we're going to be, so take that chance to press the subscribe button and also the comment down below. All right, so we can be able to move to another concept under integration using u substitution. So how do you use u substitution to do this particular question that we have done? So you see we are having the integral of 4 over 2x plus 1. So we can say this function that we have here, use u equals to 2x plus 1, so that you can be able to, anywhere you have 2x plus 1, you can be able to replace that with u. So first, once you have identified your u, find the u dx, meaning you differentiate the u with respect to x, and that's going to translate to 2. So du can be written as 2. You get that? All right. So meaning we can be able to that expression that we have at the top here, if you look at it, we can be able to simplify it so that we can be able to write it in terms of 2 dx. So 2 times 2 times 2 will give us 4. So we have not done anything strange. We just splitted that 4 so that we have 2. We combine it with the dx so that we can have this expression for du. So du is equivalent to 2 dx. And we can now write this function that we were given in terms of u. So this is going to be 2 over u, 2 over u, because u is 2x plus 1. So it's going to be 2 over u, but 2 dx is equivalent to du. So here we are going to have. Now, can we be able to integrate this? It's easy and it looks nice. We can be able to say this is going to be integral of that. We can take 2 out, but the integral of 1 over u is ln of. Then finally, we can now say replace u with 2x plus 1. Therefore, our final answer becomes 2 ln of u. But ln of u, u is 2x plus 1. So we write 2. plus c plus c. We're going to say our final answer is 2 ln 2x plus 1 plus c. Now, once we have done that, I believe you are getting value. We can be able to move further and look at integration of that involve trigonometric functions, so that you can also as well understand when you are given trigonometric function, how do you approach it. For instance, you are supposed to integrate this. You are supposed to integrate sine x, sine 2x dx. So how do we go about this one? So if you have that, you are going to say 1 over the derivative of the inner function, because we have two functions. We have function 1, which is sine. The second function is 2x. 2x is the second function. So this 2x, we are going to find its derivative, and we divide 1 over, we say 1 over the derivative of 2x. So it's going to be 1 over 2. And then, okay, let us start afresh. So I've identified this as 2x. So meaning this is going to be 1 over the derivative. Find the derivative of that one. So it's going to be 2. Then now again, we're going to find the derivative of sine, but which are right, or rather find the integral. We integrate. When you integrate sine, you get negative cosine. So it's going to be negative cos 2x then plus c. But the derivative of 2x is 2. So finally, we shall multiply that, and then our final answer becomes negative 1 over 2 cos 2x plus c. So there are things that we have done here. You identify how many function you have. The first function is sine. The second function is 2x. So 2x, you find its derivative, you say 1 over that answer you get, times now you find the derivative, you find the integral rather, you find the integral of sine function. Yeah. All right. Moving further, we can also have one more example. If you have this and you're supposed to find the integral of this, how do you go about it? I believe you've followed from the previous section. So first we have this part of 3x. So say find the derivative of 3x and say 1 over that answer. That's going to be, find the derivative of that, it will be 3. And now find the integral of cos. Integrate cos itself without looking into what's in the bracket. So cos is going to be sine. Integrate that part. So that's going to be sine 3x plus c. So our final answer becomes 1 over 3 sine 3x plus c. Okay. Further, we need to look at another scenario. Let's see what we, yeah, what do we have? Okay. All right. So evaluate this part that we have here, 0 to 1 over 2 pi, and we are given sine 2x plus cos x. So we are in, yes. Yeah, so this is going to be 1 over 2 negative cos 2x plus, integrating cos, we're going to get sine x. So the limits from 0 to 1 over 2 pi. So if you substitute the limits into that, we are going to get our answers as follows. We shall have 0 plus 1, and then we're going to have our final answer as 1.5. 1.5. Sometimes you can be given trigonometric functions which have powers. So what do you do? How do you go about it when you have a power in the trigonometric function? So that is the exact the next area we shall focus on, because you may be given like cos squared 3x. How can you go about that? Integrating on. Okay, before we move to that, let us have this one. You may have at the numerator, if you look at a function, okay, you are given a question, and then when you look at the numerator, the denominator, there is some similarity in the sense that if you differentiate the denominator, you will have that fraction at the numerator. So for instance, you have this. What you do is that this becomes k ln of x then plus c. So let us see an example which you can be able to use in such kind of a scenario. So you have this. So if you look at the denominator, whatever we have at the denominator here, if you differentiate 1 plus e to the power of x, you are going to get what is at the numerator. So in that case, now let us f of x is that. So the derivative of f of x is going to be e of x, because if you differentiate 1, you are going to get 0. If you differentiate e of x, you are going to get e of x. So we can be able to write this function as, we take these two outside, we remain with e to the power of x, 1 plus e to the power of x. But when you are differentiating, or when you are integrating such kind of function, you are going to have k is the constant, so it's going to be 2 ln of the function of the denominator, then plus c. So we are going to have that as our answer, then plus c. Don't forget that c at that particular point. Next we have this kind of integral, 6x squared over x cubed minus 1. So if you look at this x cubed minus 1, if you differentiate that, it's going to become 3x squared. But we can be able to manipulate whatever we have there so that it can become, okay, if you differentiate this, you're going to get 3x squared. Yes? All right. So 3x squared. Then we can be able to write this function that we have here in that manner. The original function that we were given can be written in such a way that we have 3x squared at the top. Then we're going to factor or take the 2 outside the integral, and then we're going to remain with this function in such a way that the top is the derivative of the bottom. Then when you find the integral of this, is going to be 2 ln of the denominator, and that's going to be, so it's all about you being keen when you are given these questions on integration. Your eyes should be wide open so that you can be able to see which particular technique can be able to fit in this particular question. Here are the rules, here are the techniques that you're able to use in various questions. So I brought in this question so that you can also know how to go about this kind of question. Then can I take you back? Let me take you back to trigonometry, whereby you have a power in the trigonometric function. Right, so we have integrate this. You have sine squared x d. So the first thing, you are going to use double angle formula to remove that power. So you know that sine squared x equals to a half 1 minus cos 2x. So this is just double angle formula. So I believe you remember that. So sine squared x can be expressed as that. Yeah, you can see now in the other side of the equal sign, we have a half minus a half cos 2x. We don't have the power. Then we can now be able to apply the previous formulas that technique we learned when we are using. So how can we go about this? So this integral, we have sine squared x dx can be written as follows. Then we're going to integrate term by term. So if we integrate term by term here, we are going to have a half x minus is going to be a half times 2x. We need to find the derivative of 2x. because 2x is in front of cosine, so we're going to say 1 over the derivative of 2x. Derivative of 2x is going to be a half again, so it's going to be 1 over 2 sine 2x then plus c. So finally our final answer becomes a half x minus 1 over 4 sine 2x then plus c. So once you've understood that, can you try this one here? 3 cos squared 2x dx. If you remember, cos 2a can be written as such. So we can be able to say cos squared a can be written as 1 over 2 cos 2a plus 1. So we are going to use this part to express that integral as double angle. So if you don't remember how to go about double angle, you need to check in the description below how to express that, because video that's going to take you. So basically, that is how those are some of the techniques that you need for you to perform integration. So finally, we're going to say plus c.